Very warm good morning all of you. My name is Samiksha Tangdev Azge and today me and my group member Akansha Jadhav are here to explain the topic. The topic is time domain response analysis of second order system. So our guide is Dr. Vijaya Kumar sir and we are from electrical department Sanjivani College of Engineering Kopargaon. Next is content. In content, first introduction, second transfer function, third advantages and fourth disadvantages and conclusion. So in introduction, what is second order system? A system described by second order differential equation. So our standard form is d square y of t upon dt square plus wc n dy of t upon dt plus w square n y of t equals to w square n u of t. So where damping ratio, natural frequency, input and output. Input is u of t and output is y of t. Next is transfer function. Transfer function is explained by Akansha. Next is simulation. MATLAB simulation is also explained.
First, we can see the Samiksha also told about the what we can do in this simulation. We can analyze the time domain function of second order system. These two transfer function we are used for the time domain analysis. First is ts equal to 4 upon s square plus 2s plus 10, and second is 2 upon s square plus 4s plus 10. For that we can analyze code or simulation. For the code I can use the command window. For in command window I can first clear the command which I can use before and also my workspace. Then I can for the first transfer function I can consider a variable. We can consider any variable, but here I can consider a variable. A equals to tf means transfer function. In first bracket we can type the numerator, and in second bracket we can type the denominator. Then type the all values and then enter. Then for the step for the graph, for the plotting of the graph we can use the step plot command, which is for the a variable. So in bracket we can enter the a, then enter. After that we can get our figure in the graph. It takes few seconds. Yes, something is wrong. Take 1 minute. Here we can get our figure, that is graph, and for the analysis. In this graph we can analyze the time, settling time, peak time, overshoot time. For that another one method is there. Data equals to step info of the function a, which we can type and simply enter. Then we can get all the value of the analysis time for the time analysis, which is rise time, transient time, settling mean, settling max, overshoot, undershoot, peak time. This value we can compare with the second transfer function's value. For the second transfer function we can again type the code, which is for second transfer function I can consider b equal to transfer function of numerator is my numerator is 4 and denominator is 1 4. Sorry, my numerator is 2, denominator is 1 4 2. So we can simply type here numerator comma denominator values, close the bracket. Then step plot of function b, then enter. We can get the another graph. In we can get this graph, but that graph and showing in screen this graph, it in this very changes is available. So first we can enter again data. For data info, data equals to step info of function b, enter. Then see here, rise time, transient time, settling time, all the function we can get here. Analyze here, rise time is 0.4 for the first transfer function, and second transfer function rise time is 0.6. Means when we can change our transfer function, our rise time, transient time, settling time, all the time domain function change with respect to our transfer function. For this analysis we can also use the simulation. Then I can show you how I can simulate model of this transfer function for the second order. Go with Simulink tab. Go with Simulink. Create a blank model. After that, it takes few seconds for give our editor window. Here is my window is open, so I can maximize it firstly. It takes few seconds for starting window. Yes, you can. This is started. So I can maximize it, and then I can start the transfer function editing. First I can get the step block for the step function. Here I can type on, double click and simply type step. I can get this block step. Then I can sum. For the sum, take connection of the sum and step. Then transfer function block is needed, so transfer function first block is there. Connect this block with the sum block. Then scope block. Then arrange it. Then change the parameter of sum block. For the transfer function time domain analysis, we need to change sum block signs due to analysis. Here is plus plus, I can change plus minus, apply and OK. Then here I can get the mux. Connection of the mux output with the scope. Second point of the mux with the transfer function, and first point of the mux is between the step block and sum block. Then here some negative sign connected with the in between the transfer function and mux blocks. Then edit the transfer function. Our numerator is 1 and denominator we can consider simply 111. For analysis, run this and enter. Run this model. Here we can get the transfer function time domain response of transfer function. Here we can change color. First go with setting. In the side of setting there is one toolbar. In that layout is also there, and we can change the color. Second option is color. Go with that tab. go with that tab, then change the color and we can apply with color. I can change color here. Some color I can take white, some color I can take black. We can check with the help of apply. Then we can also change the color of yellow waveform because of it is not that much visible. Then okay, here I can change the color and also the transfer function block. For analysis we need to take some more transfer function, but for this I can take screenshot of this for the reference. Then we can change the only transfer function. Here I can get the transfer function which is 2 upon that second transfer.
Next is advantages. In advantages, it is simple to understand and interrupt. Directly relates to physical behavior of system. Examples: oscillations, overshoot, and useful for controller design and tuning. It is well supported by tools like MATLAB and Simulink. Next is disadvantages. In disadvantages, it is limited to linear invariant we can say LTI systems. Then it does not handle frequency specific behavior well and sensitive to modeling and may become complex for higher order or non-linear system. Last is conclusion. In conclusion, time domain response analysis of second order systems provides clear insights into system behavior, and MATLAB enables to intuitive simulation and visualization. Then understanding response characteristics like overshoot, rise time and settling time is crucial for control system and design. Then despite some limitations, it remains foundational tools in system dynamics and control engineering. Thank you so much.